In this recording, we're going to walk through the fundamentals of Impala. We're going to review the need for Impala, where it came from and why it's used. We're going to take a look at the architecture, compare it and contrast it with Hive and Pig, look at some use cases of Impala, and reveal where Impala is maybe not the best tool for a purpose. First off, MapReduce is slow has always been one of the biggest and longest held complaints of Hadoop and MapReduce in general. Even the most trivial job in Hadoop is going to take 10 plus seconds to run, mainly because we have to stand up those individual map and reduce JVMs, and that's a somewhat expensive process. Data analysts are very used to working in ad hoc mode in a database or OLAP online analytics processing systems, where they expect responses back sub-second or millisecond time frame. Impala uses its own set of daemons to be able to do real-time queries and route around all of the slowness associated with MapReduce. Again, Impala does not use MapReduce at all. MapReduce is excellent for parallelizing problems and getting through a large data set, but it is not fast and it was never meant to be fast. Impala, therefore, is not fault tolerant. If a node or daemon dies in the middle of an Impala query, you have to rerun the entire query. Again, probably not a big deal with Impala when you talk about the queries completing in possibly sub-second timeframes. It does, however, still have a dependency on underlying HDFS data. It does require a Hive metastore, even if you're not using Hive. Again, this metastore is probably MySQL-based, but it will run on top of just about any database. It's likely to be on a completely separate machine, a sort of helper machine where we would run our Pig, our Scoop, and maybe our Hive service, as well as Uzi, the metastore, the state store daemon, and some other stuff. Each slave node in the cluster is going to run a single Impala D daemon. This is essentially the querying engine that Impala uses. There also needs to be a single Impala state store daemon running somewhere in the cluster. Again, this is likely to be on that same sort of helper or support machine that we were talking about running the Hive metastore on. This state store daemon essentially helps the Impala D daemons run faster by coordinating metadata operations and query planning information. Information like which slaves are up or down, where we can find certain data in the HDFS data structure, and information such as this is coordinated by this state store daemon. And again, the state store daemon is not required, but it will help the overall processes run faster. Users then submit queries to any Impala D daemon, and that daemon will take over and coordinate the efforts of the Impala D daemons, again hitting this state store daemon to coordinate these operations. State store again is not required, but your query will run much slower without it. In some ways, you can kind of think of it as the secondary name node in an HDFS cluster. It's not required, but if you don't have it running, it's going to result in slower operations. Again, we know that Impala does not use MapReduce, and Hive and Pig do. Hive and Pig will always have the limitations and the benefits of MapReduce. And one of the biggest limitations is that MapReduce is going to be slow for very, very small queries. Impala uses its own daemons and was built for speed. Impala does have the dependency on this Hive metastore, so in some ways it's similar to Hive. And it also uses a SQL-like language, which is a subset of HiveQL. Users that are familiar with Hive or MySQL will be very comfortable in Impala, but some important features like user-defined functions and custom SERDs or custom input and output formats are not yet supported in Impala, although that support is coming probably sometime in 2014 or 2015. Most users will likely run at least Hive as well as Impala. We know that Pig can run right next to Impala and work just fine. However, if you are running other MapReduce tasks or Hive queries in your cluster, you want to make sure that your slave nodes have enough memory to support all of the daemons, both MapReduce and Impala and or HBase or whatever else you're doing. Impala is very memory intensive. One of the ways that it gets these speed optimizations is that it caches and stores a great deal of the underlying dataset in memory. Let's look at some use cases for Impala. Impala is fantastic for ad hoc real-time querying. This is essentially what it was built for, and if you have these needs to get queries back very, very fast, doing exploratory analytics and so forth, Impala is going to make your life a whole lot easier. Anytime your users are complaining about MapReduce speed, you might want to consider installing and getting them to use Impala, but you do not want to use Impala for long-running queries or anywhere that you need fault tolerance. Again, we know that if an Impala query dies in the middle, the whole query fails. It doesn't have this nice fault tolerance built into it that MapReduce does. Anywhere that we're using custom ETL operations, especially ones that use custom SERDs or user-defined functions, are going to be much better dealt with in Hive or more likely Pig. Any sort of end user-facing queries, anything where our end users may be hitting our backend cluster. You don't want to let Impala do this, mainly for the fault tolerance reasons. But there are some organizations out there doing it and dealing with this bleeding edge technology by maybe rerunning the query if it fails. What you may want to consider doing instead is using Scoop to export HDFS data back into your RDBMS and then use the RDBMS for speedy queries. Again, the data that you would have generated in HDFS probably came from a pig, hive, or other MapReduce job. Hopefully that helped demystify some of the Impala fundamentals, how it's used, where we should be using it, and where we should not be using it.